Copperstring 2.0 is set to turn northwest Queensland into an economic, social and environmental powerhouse for the state and the nation. The 1,064-kilometre high-voltage network will connect the people, businesses and communities of Mount Isa, Cloncurry and the Northwest Minerals Province to the national electricity grid. This game-changing open-access infrastructure will make the region more competitive on a global stage. The UGL-CPB joint venture is proud to be part of this landmark project, having served Queensland for more than 50 years.
This is a major infrastructure project. Economically, it opens up a major part of regional Queensland and allows for effective investment and development in that region. We've worked effectively as a joint venture, UGL and CPB, with Copperstring to ultimately come up with a technical specification and solution that best suits all parties and is the best value for money proposition.
The JV are Tier 1 leaders across Australia in both HV construction and civil construction, and the combination provides to Copperstring leaders in the industry, experience in the industry, the contacts in the industry to deliver a project of this size and magnitude.
We're focused on technical excellence, delivery precision and a local first commitment powering value.
Our design solution achieves outstanding time and cost efficiency while meeting the highest quality Australian standards and the project's performance requirements.
We've worked with all the major utility clients across Australia. We've applied our experience and knowledge of substation and transmission line design to come up with a cost-effective, reliable and optimised design. Working with the Copperstring team, we created a 4 pillars process to drive value. So we're trying to build constructability and safety and design into the project up front. We're proud of the result, keeping Queenslanders and end users at the centre of our decisions.
The proposed transmission network features the backbone from Woodstock to Mount Isa, the southern connection from Dejara Road to Woodyah, and the northern connection from Flinders to Mount James. It ultimately connects to the state's electricity grid near Mulgrave, southwest of Townsville. Our solution includes a refined alignment and features options like innovative steel helical piling and guide tower structures. A major win was switching to lighter, higher-tension transmission conductors, eliminating more than 100 towers by enabling longer spans. We've reduced landowner and environmental impacts, like saving around 40 hectares of vegetation and minimising waterway crossings near sensitive riparian zones, nature reserves and koala habitats. And it will be faster and cheaper to construct and provide power earlier for customers. The project's 7 new substations include a first-time connection between a key renewable energy zone and the national grid. By increasing the transformer size at 2 substations, we've reduced the total number of transformers, thereby minimising the substation footprints. The compact, scalable design also allows for cost-effective future expansion. By achieving the smallest construction footprint, we've reduced the time and cost of earthworks, drainage, foundations and materials, while improving environmental, cultural heritage and community outcomes. Behind the scenes, we've mapped out the most efficient access tracks to each tower and substation, using existing infrastructure where possible. Again, we've created time and cost savings through less construction and have reduced local impacts, advantages made possible by our ArcGIS data modelling.
If you look at Copperstring 2.0 on a map, it's a quarter of the width of Australia. To break that area down and to be able to view it in one place is a very difficult thing to do. So that's where the benefits of that ArcGIS system come in. It allows you to break the job up into segments. It provides a collaborative workspace for everyone to view where the design is at its current point in time, and also to identify whether there's any clashes with government information or information that's already been identified. As soon as you've put that information into the system, you can pretty much ask any query that you want of the system. So there's a whole range of things that we can do with it. The power of the GIS system in the field is that all of that map information is available to the field crews at their fingertips.
Our construction strategy has again saved time and costs and will fast-track delivery while keeping community and environmental values front and centre. With more than 1,900 tower sites alone, the logistics of people, plant and materials is key. We've created 9 strategic logistics hubs based on our GIS modelling. Each hub's unique setup uses the same logic, like optimal laydown facilities, direct materials supply, and a light construction footprint. We'll have reduced interaction with the local traffic network and communities, while reducing crew travel time and improving productivity, meaning efficient, safe, low-impact construction. Our zone-based staging plan takes that further, delivering value and better quality control throughout construction.
So on a project that's long and linear of this nature, staging becomes critical. Our approach to the work zones has been focusing on trying to reduce the overall travel time, so keeping each of the 9 hubs self-sufficient within a 1-hour driving distance of each other. The 1,100 kilometres of the project is split across 7 weather regions. There's a key indicator east and west of Pentland where we have higher rainfalls on the east and higher wind zones through that cyclone banding than we have on the west. We've probably run about 24 scenarios for the sequencing work and where we would start first and how we would really maximise the efficiencies along the alignment.
Safety in delivery has been at the heart of our approach. With more than 1,000 kilometres of high voltage lines, our team is using UGL's patented pin and pot method for transmission towers. By lifting and placing tower sections into place without working under suspended loads, we're dramatically improving safety. Other innovations, like using helicopters for stringing cables, reduce the number of people working at heights and improve construction efficiency and safety. Throughout design and construction, Copperstring 2.0 is set to create more than 800 construction jobs alone. Our training and upskilling strategy, working closely with local training providers, means local communities have priority access to these jobs. This includes engaging Indigenous employees for a range of project roles, including cultural heritage monitoring. Our school and university engagement will further encourage the next generation, with ongoing operations and maintenance in mind. We also estimate procuring more than $200 million in goods and services from the local region. Particularly in civil construction services, we're seeking every opportunity to direct economic benefits to the project's local communities. This includes offering flexible, smaller work packages for local and Indigenous businesses, and encouraging partnerships to build long-term capability.
Both UGL and CPB have delivered projects in remote regions, and in doing so, it's very important that we lock into the local communities. We will be engaging for services, subcontractors, as well as staff for employment. We also want to play a positive part in the local communities and leave a legacy for Queensland.
This is a great project. I think we're all very proud to be part of this project. It's very challenging. It will affect positively a lot of people, and this is the kind of flagship project that we like to be involved in and that we like to deliver.
Technical excellence, delivery precision, and a local first commitment. This is how UGL and CPB are powering value for Copperstring 2.0.